Over 7 episodes, we built a fraud engine. Streams, windows, per card state, patterns, mitigation, and it survives a machine dying. And in a demo, with traffic you generated, it works beautifully. Now it has to run on the busiest shopping day of the year against traffic you did not design. And every single card it freezes by mistake is a real person standing at a till with a queue behind them, whose card just got declined. This is the finale, and it is about the difference between an engine that detects fraud and a system a bank will actually let you turn on. Start with what you watch, because most dashboards for systems like this measure the wrong thing. CPU and memory tell you the machine is alive. They do not tell you the engine is working. The number that matters is lag, how far behind real time you are. An engine at 30% CPU that is 4 minutes behind the stream is failing completely. And it is failing silently, because every alert it produces is arriving after the money left. Then latency through the mitigation path, measured at the tail, because the transactions that matter are the slow ones. And then the rate of matches per rule, which is your early warning that a fraud pattern has shifted, or that someone changed a threshold and did not tell you. Now tuning. And this is where architects who have never carried a pager get it wrong. Every threshold in this system is a trade between two kinds of being wrong. A false negative is fraud you missed, and it has a price the bank can put on a spreadsheet. A false positive is a real customer declined, and its cost is much harder to see and usually much larger. A support call, a complaint, and a person who now keeps a different card at the front of their wallet. Tighten the rules and you catch more fraud and annoy more customers. Loosen them and the opposite. There is no setting that is simply correct. There is only the trade, and the mistake is not choosing badly, it is choosing by accident, because someone picked a round number in a sprint 2 years ago and nobody revisited it. Which brings us to the thing that turns this from a project into a system that gets better. Every alert eventually gets an answer. An analyst confirms it was fraud, or the customer phones and says, "No, that was me, I was on holiday." That outcome is the most valuable data your organization produces about this problem, and in most banks it dies in a ticketing system. Feed it back, route confirmed outcomes into the same stream, and now your rules have ground truth. You can measure a rule's actual precision instead of arguing about it. Retire the ones that only ever fire on holiday makers, and tune thresholds against evidence. This loop is also the only honest place machine learning enters this series. A model needs labeled examples, and this is where labels come from. Rules first, labels from the loop, then a model that scores what the rules surface, not the other way around. So look at what the whole series adds up to. An event designed for the questions we would ask later. A stream partitioned so ordering and parallelism come free. Windows that catch a burst without a database. State that survives a machine dying. Patterns an analyst can read. A mitigation path that is idempotent because we knew a replay was coming. And a feedback loop that makes it sharper every week. None of those is exotic on its own. The architecture is in how they fit, and in the decisions we made deliberately instead of discovering at 2 in the morning. That is the job. That is real-time fraud detection, end to end. If you want the whole build in order, the full series playlist is linked in the description. The next series takes the same treatment to a different hard problem. Multi-tenant SaaS data architecture, where one query bug means one customer reads another customer's data. See you there.